Okay, hello everyone. We are Group 5 and we did our project on 3D printing accuracy and quality analysis. My name is Zachary Verbis.
Model McMurray.
Jacob Gettinger.
Yeah, so the objective of our research study was to analyze how factors such as the infill percentage, printing speed, and the printing temperature affect the overall accuracy and the quality of the 3D printing objects. We also wanted to test how these factors affect the mass of the objects using ANOVA test suite. We wanted to test the pairwise interaction between these factors. We tested our hypothesis at 0.025 confidence level. Next slide, please. Regarding the experimental design of the three factors ANOVA tested without replication, we were able to save time and resources in our experiment and overall analysis of the data. Since all possible combination of factors described in the objects as independent variables, we were tested. This was a very time-consuming process. To perform this analysis, Meta was used in order to make this portion faster regarding the analysis. Next slide, please.
So the factors we chose are pretty self-explanatory, but we chose 5 different printing temperatures to test, 3 different infill percentages to test, and 3 printing speeds to test. The response variables that we were interested in, as stated before, were dimensional accuracy, quality, and mass. The dimensional accuracy was taken as the difference on each axis from what the print was instructed to be, the measurements given. The quality was judged by group members on a scale of 1 to 24. And the mass, obviously, again, taken as the difference from what the overall mass of the material used should have been. The 3D printer that we used was an Ender 3 Pro V2 from Creality. We were using a 1.75 millimeter PLA filament with a 0.4 millimeter nozzle for extrusion. The slicer used was an Ultimaker Cura. And for the design of the cube, we chose to print a cube because it gave us flat edges, which were a good reference for our measurements. And the sloped overhanging walls of the cube made the path of the print slightly more complicated, so it wasn't too easy. It also saved a little bit of material and printing time.
With regard to how to perform the experiment, for 4 out of the 5 responses, precise measurement devices were required to ensure that there was no external influence. For the measurement in the X, Y, and Z directions, a caliper was required to measure the small differences in distance. The caliper used is an absolute origin caliper with an accuracy of plus or minus 0.01 millimeter. Looking closer at the images to the top right, it can be seen that the model doesn't incorporate the flat edge that was previously spoken about, which is perpendicular to the base, as a good reference for the caliper. Multiple measurements across each of the cube's dimensions were taken, and the measurement with largest discrepancy was recorded. For the measurement of the mass, the scale was required to measure the small differences in this mass. The scale has an accuracy of about plus or minus 0.01 grams and is able to be calibrated. To calibrate it, it calls for a 100 gram mass as a reference, and this calibration was done for every print to ensure consistency. Another thing to note is that for each print, a priming strip is laid down on the hotbed at the start to ensure that proper flow through the nozzle is occurring, and this additional mass was accounted for. One of the 5 responses, quality, objective measurement, was quantified through a scale of 1 to 24, 1 being the worst / low quality and 24 being the highest or high quality. 2 images for each of the 45 combinations were recorded in the response matrix, and it was asked of each group member to look through this response matrix prior to rating to ensure an appropriate relative measurement was assigned. The average of each factor combination's ratings was recorded.
So there's a few things that were kept consistent across each print. For instance, the hotbed was allowed to cool down before each print, and everything was cleaned, including the nozzle. The layer thickness was kept consistent as well as the hotbed temperature and fan speed. The first layer had to have specific privileges. So the first layer was printed at 195 degrees Celsius and 25 millimeters per second, just because we weren't really testing plate adhesion. And here's all the tabulated data. So here's a summary of the main effects and interaction effects. So the main effects of printing temperature was pretty much everything except the Y directional differences. Printing speed also had a big effect on the mass quality and X-dimensional accuracy. Percentage infill by itself didn't really have an effect on dimensional accuracy or quality, but the interaction effect of infill percentage and print speed did have a pretty significant effect on quality and dimensional accuracy. Printing temperature and printing speed also had an interaction effect for quality, and print temp and infill percentage had a mass difference. So the main conclusions, basically printing at 180 degrees is not worth it. Anything above 190 should be good. Also, infill percentage only really had a significant impact on mass difference, but when you pair that with different printing speeds, it does become important. Printing speed should be less than 90 millimeters per second in interest of mass and quality.
For this project, we had issues, and what we have learned. One of the issues that there were many ways to look at the analysis data and the team management, and the factor response variables was a challenging task. And on the other side, what we have learned is that with only one sample for each combination of the factor flavors, we still were able to capture interesting and useful results, how to select the appropriate analysis. We had fun facts where it took about 28 hours to print all the 45 cubes, and all cubes consumed about 159 grams of material. 3D printing origins can be traced back to 1983 using a technique called stereolithography.